we have reached basic properties of halogens, group 17 elements. So what are the general characteristics of group 17 elements? At their atomic and ionic radii. They have smallest ionic radii in their respective periods due to maximum effective nuclear charge. Then ionization enthalpies. Now the ionization enthalpies of halogens, they are very high. Melting and boiling points. The melting and boiling points of halogens, they increase with increase in atomic number as we go down the group. Then electron gain enthalpies or electron affinities. All these halogens, they have maximum maximum negative electron enthalpies in their respective periods. They have maximum tendency to accept an additional electron. They have maximum tendency, their electron affinity is very high. It means that negative electron enthalpy means electron affinity. So all these halogens, they have very high electron affinities, means they have maximum tendency to accept an additional electron. In general, negative electron enthalpy decreases from top to bottom in the group. This is due to increase in size of atom from top to the bottom. So as we move down the group, the size of the atom increases. When size of atom increases, the attraction towards attraction of nucleus towards electron, that will decrease due to increase in size. So as we move down the group, electron affinity also decreases. Then next we have very important property of fluorine. Now fluorine has unexpectedly less electron gain enthalpy than chlorine. Now fluorine should have maximum electron enthalpy because it is smallest in size amongst all the halogens. But it has less electron enthalpy than chlorine. This is anomalous behavior of fluorine. Now the lower electron affinity of fluorine, that is, it is due to very small size of fluorine, which leads to strong inter-electronic repulsions. Now what happens due to small size of fluorine? There are inter-electronic repulsions, repulsions within the electrons which are present inside the fluorine atom. In the relatively small 2p subshell of fluorine, and thus the incoming electron does not feel much attraction. So there are strong inter-electronic repulsions, which lead to due to which the incoming electron does not feel much attraction. So, and electron affinity among halogens, it varies as fluorine, it is less than chlorine, but chlorine is more than bromine, then bromine has greater electron affinity than iodine. So amongst all the halogens, chlorine has maximum electron affinity. Then next we have electronegativity. Now halogens have large electronegativity values. Fluorine is the most electronegative atom in the periodic table. This is we are talking here about electronegativity and not about the electron affinity. So halogens, they have very large electronegativity values, and fluorine is the most electronegative element in the periodic table. Metallic or non-metallic character. Now due to very high ionization enthalpy values, all halogens are non-metallic in character. The non-metallic character decreases as we go down the group. So all halogens are non-metallic in nature because they have very high ionization energies, means they have very less electropositive character. But as we move down the group, their non-metallic character decreases. Why it decreases? Because the size, it keeps on increasing as we move down the group. So ionization enthalpy values, that also decreases as we move down the group. Now color. All halogens are colored. Fluorine is light yellow in color, chlorine is greenish yellow, bromine is reddish brown, iodine is dark violet in color. Now the color of halogens is due to the fact that the molecules, they absorb radiations from visible light, visible region of the spectrum, and their electrons, the outermost electrons, they are easily excited to higher energy levels. Higher energy levels. And in this course, when the electrons, they are when the electrons, they are excited to higher energy levels, when they lose their energy, they will emit radiation of a particular wavelength. जब वो अपने एक्साइट होने के बाद जब वो अपनी एनर्जी लूज करते हैं और बैक अपने ओरिजिनल ग्राउंड स्टेट में आते हैं, then they what happens, then they lose their energy, then they lose energy in the form of radiation which has a particular wavelength and which corresponds to a particular wavelength, और उस wavelength के corresponding जो color होता है वो color हमें आपके halogen का नजर आता है. So all halogens, they are colored. Then next we have the oxidation states. Now they show an oxidation state of -1 or +1. Yes, they are highly electronegative, they have high electron affinities, so they are except fluorine is the most electronegative atom, and it always shows an oxidation state of -1. Yes, its oxidation state is always -1. Other halogens, they can have -1 or +1 oxidation states, and they can even have positive oxidation states like +1, +3, +5, +7. Now the higher oxidation states of chlorine, bromine and iodine are that is due to the presence of vacant d orbitals in their valency shells. Yes, they all have vacant d orbitals, so they have tendency to show higher oxidation states. As a result, the outer s or p electrons can easily be promoted to vacant d orbitals, and that is why they show higher oxidation states. So thank you.